So we've learned how to find basic derivatives, and now we get to products. So whenever you're finding the derivative of a product, you're trying to answer this question. What is the derivative of f of x times g of x, if f of x and g of x are two separate functions? So obviously most of our derivatives have been intuitive thus far, so we think, is it simply their derivatives multiplied together? Well, let's take a look at this quick little example. So if we had x squared times x cubed, and we're finding the prime of that, or the derivative of that, we're wondering if it's the same as looking them separately, finding the derivative. Okay. So we're going to work each side separately. So on the left, if we were to actually multiply those together, we know it would give us x to the fifth. Right? And if we took the derivative of x to the fifth using our power rule, we would get 5x to the fourth. Now coming over here on the right, if we take the derivative of just x squared using the power rule, we would get 2x. And then if we did it for x cubed, we would get 3x squared. And then if we multiplied these together, we would get 6x cubed. And oh no, this does not look good. Okay, so unfortunately, the product rule for derivatives is not quite as intuitive as the ones we've worked with thus far. Okay, so we're going to kind of create our own function p of x, as in product, which represents the product of two other functions. And we're going to try to do this approach with the original limit definition of the derivative. So p prime of x would equal the limit as h goes to 0 of f of x plus h, which in this case would look like the two functions with x plus h being multiplied, minus f of x, or p of x I should say in this case, which would be f of x times g of x, all over h. So again, I'm using this function with the original definition of the limit, so plugging x plus h and x into that product. But now what? I don't really see how we can do anything here to simplify. And this was a common issue back when people were first trying to figure this out. And so we actually are going to take a geometrical approach to explain what this numerator can be turned into. And for this next part, you really don't need this in your notes. I'm just trying to give you a way to understand where the formula for this all comes from. So the first thing, when we're talking about products, and I'm talking about thinking of them geometrically, we often will think of a rectangle, right? That was kind of the first way we thought of products in terms of shapes, or squares and rectangles. So in our function we have this big rectangle, so to speak, and we're taking away a smaller area of that rectangle. So this big rectangle is going to represent we'll call it the width. Let's go with g of x plus h. And we'll call the entire height of this big rectangle f of x plus h. And their product is the area of this rectangle. And we're going to subtract a smaller rectangle area from it. Okay, and this smaller rectangle area, it's going to represent what we're taking away or subtracting, which is the area of f of x times g of x. So we'll call this smaller height f of x, and this smaller width g of x. Okay. So again, we have a giant area here, and our numerator will simplify to this giant area minus this smaller area. So basically what we need to find a way to represent is this area in between. So let's look at this top rectangle first and how we would express that. So this skinny rectangle would have a height here of the difference in f of x plus h minus f of x. So let's come down here. I'm going to kind of give myself more room. So the width would be f of x plus h minus f of x, and or I guess the height, whatever you want to call it. And the other dimension going across here, that's going to be this entire length, which is represented as g of x plus h. So the width times length, or base times height, ooh, I got a little mixed up there, can just be represented in this way. So that's that part. And then for the other area that represents the difference between the rectangles, we have this little guy here. Okay, so for this one, this width here, so to speak, is represented as the difference between g of x plus h minus g of x. And it's getting multiplied by a length of f of x. Isn't this fun? I know, I think so too. Okay, so basically our numerator can be boiled down to these expressions right here being added together. Because as a total, it represents the difference in f of x plus h times g of x plus h minus f of x times g of x. It's represented by this entire area here, which we have now written as this in combination with this. So, okay, let's go back here and make this happen. So now our entire numerator will turn into f of x plus h minus f of x, all multiplied by g of x plus h, plus g of x plus h minus g of x, all times f of x. And then this, of course, is still all over h. Now, somehow it looks like we've gone from something more simple to something more complicated, but give me this next step and I think you'll see where we're headed. So we're finding the limit as h approaches 0, and I'm going to break these up into two separate functions here, just because the plus sign allows me to do that. So let's break this up. Okay, so are you starting to see something familiar? Well, f of x plus h minus f of x all over h, that's the basic definition of what f prime of x is, right? If we were to just kind of break this off. And then we would still be multiplying by g of x plus h. That wouldn't have gone away. However, if h is approaching 0, that would just turn into x plus 0. Okay, and then over here, again, this is our basic limit definition for what g prime of x would be. And then we have that times f of x. Okay, so this is actually giving us our definition for the product. So our product rule can now be written as the derivative, or f prime of x, times g of x, since h went to 0, plus g prime of x times f of x. Dun, 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 dun. So, real easy, right? No problems here. I do kind of have a saying I say in my head, but for that to work, I actually reverse this whole thing. So it would look like such. It goes first, d last, plus last, d first. Okay, what are you even talking about, Miss Wright? Well, basically, if you think of having a first function and a last function, or function 1 and function 2, this is the little saying I'll say in my head each time, or the first function times the derivative of the last function plus the last function times the derivative of the first. So, first d last plus last d first. So let's actually put this to use. So find dy dx if y equals 2x plus 5 times 3x minus 1. Okay, so with my little phrasing, this would be considered the first function, and I would be considering this the last function. So for dy over dx, I do the first function unchanged, so 2x plus 5. So first d last, derivative of the last function. So the derivative of 3x minus 1 would just be a 3 plus 0, or 3, plus last d first. So the derivative of the first would be just a 2 and then a 0, so 2. Okay, and again, you can leave it like this if you're just answering a question for me. It's not multiple choice, this is fine. Of course, we can also simplify it. That would be 6x plus 15 plus 6x minus 2, which we could then simplify to say, let's see, that and that would become 12x, and 15 minus 2 would become 13. Okay, so either form of those is fine with me. On multiple choice, they're likely to put the second one. So with a problem like this, a lot of you might think, well, couldn't I just multiply that out? Yeah, you absolutely could. And then we could take the derivative of 6x squared plus 13x minus 5, which if you see where we're going with this, that would be 2 times 6x to the 2 minus 1 plus 13, and then the 5 would go to 0, and that looks a lot like what we just got. So yeah, with some of these problems, there's definitely more than one way to do them. So why do we even need to know the product rule? Well, let me tell you, it's going to save you a lot of headache. So for our second example, y equals x to the 18th minus x to the 6th plus 3 times 3x minus 2x squared. Well, you can sit there and multiply that out if you would like, but the more we get into this stuff, you'll notice the more complicated it will get, and you're really going to want to be comfortable with this product rule. So first, unchanged, times the derivative of the last. So 3x will become 3, minus 2x squared will become minus 4x, plus last, unchanged, times the derivative of the first. So that would become 18x to the 17th power minus 6x to the 5th. Sorry, my dog's really excited about these derivatives. So for one like this, I'm just going to leave this. I don't feel like multiplying all this out. But the general idea is exactly what you see here, or first d last plus last d first. That's all you got to know for the product rule.